Hi everyone. So I've designed a tool for faster labeling of images for training YOLO models. So in summary, I label just a few images with the tool and then I train a model with just those few images, and I can use that model to assist with labeling of the rest of the images. So this is the GUI, and I vibe coded this in Python with the help of Claude. So I've tried other LLMs, but none of them seem as good as Claude. Just to be clear, I don't have any affiliation with Claude, and I pay full price for my subscription. I put all my Python code on GitHub, so you can have a look at that and download it and do with it whatever you like. The commands now for labeling the images are on the left here, and the image list box is here on the right. Okay, so the first thing we have to do is we load the images. So we're loading, I'm using these clover images, which are weeds, because I'm making a robot gardener. So I want to be able to classify weeds. I want it to autonomously be able to go and pull out weeds. And then we set our output directory for the output images and labels. So I'm using this YouTube out directory. So I'll just show you this. So this is the out directory, so it's got nothing in it at the moment. So this tool does two things. It does bounding boxes, and it also does key points for pose estimation. But I'm going to give you a demonstration of the bounding boxes first. All right. So this is our first image, and we just basically, class 0 is our weed and class 1 is the weed cluster. So I'm using two classes. So that's a weed, that's a weed, that's a weed, this here is a weed, and then class 1 is my weed cluster. So this is a weed cluster and this is a weed cluster. Okay, now save and next. So I save this and I move on to the next image. So what happens when we save it, now that we saw before this was empty, it saves the images in the images directory and the labels in the labels directory. So that's what the labels look like. They're just our normal YOLO labels. And when we do our training, YOLO looks for this directory structure with the images and labels directory when it's iterating through the images that we give it in the training instructions. Okay, so now let's do this one. I'm just going to do 4 images and then train the model and then use it to assist on doing the rest. Okay, so clusters and individual. Okay, so now we've got 4 images. I'm going to get to the 5th one. I'm not going to bother with the 5th one because I'm going to run my model on these 4 images. So let's have a look now at this is our output directory, and I'm going to add a couple of things to this directory. So the first thing I'm going to add is this YAML file. And the other thing I'm going to add is this script for running the training. So the YAML file basically tells us where the training data is. So I've used the same directory for training, validation, and testing, just because I've only got a few images. But as I get more images, I can change this up. And then it's also got the classes. So there's 2 classes, and these are weed and weed cluster. Okay, so now let's go to VBA, sorry, not VBA, VS Code, and we can train this with VS Code. All right, so let's open our training image, our training script, which is here. And I'm using this as our pre-trained YOLO model, which is the S model, and S stands for small. Now, if you're using YOLO, they have a number of models with different size, which have a different number of parameters. And if you've only got a few classes, you're going to get much better results with the smaller model, because otherwise you're going to get overfitting. If you've got a lot of classes, then it might be worthwhile to use a larger model. But because I've only got a few classes, I think the smaller model is going to give me better results. And so there's a little bit here at the end of the code that copies the best weights in this training to the current directory, and this way it makes it a bit easier to find when I have to load it with the GUI. You don't have to do that, but I just found it makes it easier. So let's run the training and then come back and load the model to assist us with the rest of the labeling. Okay, I'm going to speed this up by the magic of cinema. Okay, so now we've trained the model. Let's load it into our GUI so we can load the model here and we can use it to help with our labeling. So it's in, this was our output directory and this is the model that we trained. Okay, so let's open that and let's run the inference. All right, so that looks pretty good. I mean, there's a couple that it's missed up here, like it's missed this cluster. So we only have to really label the parts that it's missed. And this one here, that looks all right, that looks all right. This is a cluster here. This is another one that it's missed. And then this cluster here, it's missed as well. So, all right, so now we can save and next. See, so now that's much faster. Now we run the inference again and we see this. Okay, so it seems like it's all good. It's missed a couple of single weeds, which is this one here, this one here. Save and next. Okay. All right, so that's not really a weed. That doesn't really look like a weed. So if I do that, then what I can do is delete selected box. And now I can, and I don't really like this cluster here. So I'm going to just adjust this a little bit, make it tighter. And then I can also select this one here. So while this isn't perfect, it does help a lot. Now this one. All right. So you can see that this labeling is actually quite good and it's actually going to save us a lot of time. Save and next. Run inference. And we can keep doing that and then retrain the model. And it's going to make, it makes it a lot faster to do the labeling. In the next scene, I'll show you how we can do key point labeling as well with this tool. I'm going to do that on some images of the robot hand that I've collected because I need to estimate the pose of the robot hand for my autonomous robot gardener. Okay, hey everyone. So the next thing I'm going to show you is key point annotation for pose estimation. So I'm going to do this with robot hands because I want to estimate the pose of the hand when I'm doing some autonomous gardening. So select the input and then the output directory, out hand. Okay, and now I've got this hand which I want to just define some key points. I want 2 key points for the end of the fingers, the left finger and the right finger, and 1 for the base. All right, so let's select the class and then I go to key point and I select the box and class naught is the left finger and then key point, actually I've got to put 3 in there because I'm going to export 3 points to my labels file, and then class 1 is the right finger and then class 2 is the base. Okay, and now I save and next, and let's have a look at the labels. They're in here. So our labels are, the first label is the class, and then these are the coordinates of our box, 1, 2, 3, 4, and then these is the coordinates of our key point, and 1 if the key point is visible, and it has a 0 here if the key point is not visible. Okay, So that's pretty much it. And like I said, I'll put all this up on GitHub so you can have a look at it in your own time and do with it whatever you like. But I'll see you in the next video. Thank you for watching.